Welcome back to WebRTC Live. I'm your host, Aaron Syme, founder and CEO of WebRTC.Ventures. WebRTC.Ventures is a custom design and development agency focused on building live video applications. Here to help you take your application live. You can learn more about us at WebRTC.Ventures. Thanks for joining us live today on YouTube, LinkedIn, and Twitch. Welcome also to any of you watching a replay of today's broadcast. For those of you with us live, you can ask questions throughout the stream by leaving a comment in whichever platform you're viewing this. And we definitely encourage questions and comments throughout the conversation. For today's episode, I'm joined by Renan Dincer. Renan is engineering manager at Cloudflare, where he has led the development of Cloudflare Calls and Cloudflare Stream. Thanks for joining me today, Renan.
Hey, how's it going?
It's great to have you. Really appreciate you being here. Looking forward to this conversation. We've already talked about some interesting topics off air and kind of preparing for today. So I know this is going to be an interesting conversation for our viewers. And like I said, definitely encourage questions for any of you watching us live. But let's start with a little bit more about your background, how you got into WebRTC, and kind of what was your path to becoming an engineering manager at Cloudflare.
Sure. So, I joined Cloudflare in about 7 years ago. And when I joined Cloudflare, we didn't really have, any media products. And we were starting to think about these things. We were also starting to think about kind of a lot of the very successful products that, we have now, like Cloudflare Workers and kind of some of the edge compute stuff. And Cloudflare was going, from, a DNS provider and like a CDN provider to something, bigger, something, now people use a lot of words like edge compute, a different kind of public cloud. People call Cloudflare many different things, when they're coming from different perspectives. But yeah, we were thinking about these things and we started working on Cloudflare Stream kind of around then. And I kind of learned a lot about kind of media and like video streaming and all these kinds of things at Cloudflare, just like listening from customers and like what's needed, what's the technologies available, and kind of trying to ignore, the built up knowledge that people had because technology changes so fast that it's very easy to get stuck up on, oh, this is how you do this, right? And this is how you do this. So I learned that through that. And then, definitely coming from the broadcasting and like the video side, WebRTC is very interesting because, basically since Steve Jobs killed Flash, we haven't had low latency, proper low latency broadcasting.
Right.
WebRTC is kind of interesting because it's everywhere, and even though Steve Jobs, even though it's difficult to make this work on the iPhone without an app, WebRTC works on the iPhone, right? And isn't that crazy? So, I think we got into WebRTC because of that and because it's interesting, but then we stayed because there's a lot to do with WebRTC and, people who want to do low latency things, whether it's for like gaming, data communications, and like, moving around where your character is across many players, or if you want to have a conversation like this, you use WebRTC, and there's a lot of use cases for it. People, at some point to do low latency, you need UDP communications. And WebRTC is the only way you can do UDP out of the browser, right? And well, now that is becoming sort of incorrect, but for the longest time it was the case. And I think we are interested in WebRTC because of that. You can do very interesting things, and one of the things that Cloudflare does really well is low latency stuff because we have many locations around the world. So that's kind of like, where the journey I took with WebRTC and kind of the other media stuff that we do, just kind of listening to customers, really.
Yeah.
Figuring out what needs to be done. In the end, it's just code, right? Like, you learn technologies, and it's just like, you do stuff when people ask for stuff, and that's fun.
Exactly. Yeah. So you mentioned kind of coming at this from a little bit of a like a broadcasting and live streaming type
Yeah.
of background or use case. Is that the primary use case for using Cloudflare, or what types of use cases and clients do you typically work with?
Yeah, I mean, obviously, we're coming into, so we have two products that we sell that uses WebRTC. One of them is Cloudflare Stream, and Cloudflare Stream is like regular broadcasting, one-to-many kind of thing, where we support WIP and WEP, which is super interesting because standardized signaling for WebRTC. It's been a discussion forever, and seeing the success of that for the broadcasting use case is very, very cool. So we do that, and that's something that we do. The other thing we have is Cloudflare Calls, which is a little bit different. It's kind of like an SFU, and actually, the WIP and WEP is built on Cloudflare Calls. It's just the you can have multiple participants and do kind of more of the things that you can do with an SFU. Yeah, so we do a bunch of different things with WebRTC, besides broadcasting stuff.
Right. Right. Absolutely. So yeah, so you could do work with a variety of different like ingest, I presume, then for getting the video into Cloudflare and then distributing it. That could be WebRTC or it could be something else. I mean, like there's a big blog post up on WebRTC hacks right now about using WebRTC and OBS, and that allows you, right, to bring in some other to use WebRTC or maybe use other broadcasting standards to get your ingest to record our conversation like we're having now, but then still distribute it over Cloudflare and using WebRTC or HLS if you wanted to, right?
Yeah.
So excellent.
Yeah. Yeah, exactly. Like, people, it's kind of funny because that, obviously OBS wants to use WebRTC because there's this like, super cool low latency element of it. And people like low latency because, with the internet, you can have kind of audiences and chat windows and all these different things. And it's, not like your regular TV, where, it's a studio and you can have much more authentic conversation with the people producing. And that's, awesome because that's one of the things that, internet enables, that like kind of two-way communication. But also the other thing that's cool about WebRTC is that, you can go live from the browser. I'm currently using a browser to do this, right?
Right.
And that's super cool.
Right.
And the, that is super cool. If you can make, and a lot of people work on this kind of thing, but I would love to see, OBS like things come up that work in the browser. And like, I share like, I don't know, 5 screens, and then, I have a bunch of cameras, and then they're all going through the browser and doing stuff. Like, I think that'd be so cool.
Yeah.
Like that kind of studio thing. And you can do that, with HTML canvas element or whatever. It's not that hard. It's definitely easier than, writing C. And, to me at least.
No, I would agree. Yeah, definitely. I mean, you can use something like OBS certainly to have sort of the ultimate and power of layout and how you handle those inputs and get them out. But traditionally, it's been harder to get a live conversation like this into into OBS using WebRTC, but that's not really the case any longer. But then, shout out to StreamYard, which we use for this with WebRTC Live, where you and I are both, doing all of this through the browser, and we get some fun layout changes, but not quite as much as you might have in OBS, right? So there's a whole range of solutions that you can do, but that's kind of all talking about the ingress side, essentially, how we produce and create the content. And then there's that egress side of things too. And how do we distribute this out to a global audience and make sure that it's as low latency as possible for that. And so maybe that gets us to a little bit of like Anycast routing. which is, we'll talk about a variety of things today, I'm sure, but our main topic, learning a little bit more about Anycast routing. You did a presentation on this recently at ComCon UK, and love to hear a little more from you about what is Anycast routing and how do you use it at Cloudflare? What are the benefits that offers?
Okay, so this is kind of a difficult conversation to have because when people talk about Anycast, it kind of breaks a lot of the assumptions that we make about computers. Because kind of, for example, one of the key things we assume is like, when you make a server on, whatever, AWS or whatever you're using, it has an IP address, right? And then like, if you try to SSH to that computer or like, send a packet or whatever, you enter the IP address and it goes to that computer, right? And
Right.
in your mind, you're like, oh, your home computer has an IP address. And you're like, if I send the packet to the IP address, it just goes there. But that's not, there's different ways of doing this too. And, it makes you think of like, what is the internet? And kind of when people are, talk about internet, it's like a network of networks. And like, what does that even mean? So kind of what Anycast, I'll try to describe what Anycast is in a good way. I haven't found a great way of describing it to like a very big audience. And there's people at Cloudflare whose job is to, describe this all the time. So, probably not doing a great job. But, when you're when you send a packet from your computer, it goes from your, computer to your router, and then your router to down the street to another router. And then, from there to probably your ISP's, HQ or whatever. And then from there, it goes to somewhere else that, hops around the internet, depending on where you're going to. Maybe it's going to cross the Atlantic or whatever. And then it eventually finds itself to whatever server it needs to go. Mm-hmm. And these hops, in each hop, there's some logic that runs that determines, okay, there's a packet that came through here. Where does it go? Right. And when you're kind of, that logic most of the time is configured so that a packet has a single destination. Mm-hmm. But it is also possible that a packet can have many different computers that will accept it, right? And, that's kind of what Anycast is, where you can have multiple servers around the world. I have a diagram showing this, by the way.
Yeah.
Let me try to pull it.
Bring that up here.
Okay. So, there we go. Thank you. In Unicast, which is like what we see, like each server has an IP address, and then like you can also have it so that every computer has the same IP address. And then when you send a packet, depending on what the opinion of the in between routers are, they will send it to the closest location. At least most of the time they send to the closest location because that's the lowest cost option, right? You don't want to send a lot of packets from, say, like, using the undersea cables, because then you would saturate the expensive undersea cable capacity. So you just would send it to, if there's somewhere down the street that it can go to, it wants to go there. So that's kind of what Cloudflare does, where Cloudflare's architecture, most of the traffic, majority of the traffic that we send and receive over applications like, we have authoritative DNS, we have a content delivery network, we have Cloudflare workers, which runs edge compute. We do DDoS mitigation. This, all these kinds of things we do that all run on this kind of thing. And this architecture allows you to have very, very low latency to the closest place, because you leave it up to the internet, which is at a whole very efficient to get packets place to place. So that's kind of what Anycast is, and we have a lot of these computers around the world. So which kind of makes Cloudflare act like one big computer that is kind of everywhere all at once, which is kind of a powerful concept, because you can do very cool things with this kind of architecture. And one of the coolest things, you can get is applications where you want resiliency. If one area, one data center goes down or one server goes down, it automatically fails over to the other one. Or where you want performance, where you're very close to places. You want DDoS protection. Because of the internet, if you launch a distributed denial of service attack, it'll go to all the machines at the same time, so it'll distribute itself away. So there's a bunch of kind of benefits to having this kind of setup, where you can just distribute away all your problems, and have it act like one big computer. So that's what Anycast is, and we do a lot of it, and it's kind of interesting. From a oh, very good. We have a list. Like you can also have uniform software things, and you can scale it because you can add more locations as you want. So there's a lot of benefits to Cloudflare. To Anycast. But what was your question? I described Anycast, but I forgot the question. I'm sorry.
No. You. The question was, tell us about Anycast. So no, you did a great job with that. And CDNs in general, I'm old enough to remember initial CDNs being built and thinking about it for like static content on your website, so that could be hosted globally, even though your website was on one server sitting on one continent. We don't even at that time. We're talking ancient internet history here. That doesn't have to be the case anymore. But now we're really talking about using this for very dynamic content for live streaming. So, is there any from if you were implementing Anycast, do you have to think about different things? Are there unique challenges or complications when you're dealing with a very, like live streaming video, very dynamic content, and trying to deliver that globally with as low latency as possible? It's different than, just pushing out a static asset to 200 servers around the world and calling it done, right?
Yeah. I think there used to be two separate worlds, right? There used to be the, broadcasting world where, you would use static assets, you would use HLS, you would use, HTTP requests that are very, very simple, and it scales very, very well. And you can do, all these kinds of things using very, little compute, very simple architectures. And call it a day, and that's and then that's great, right? It scales very well, it's very cheap, it's a commodity product that you can buy from many different people, balance them out, whatever you want to do. You can have all these kinds of things on the broadcast side, but the other world is the telephony side, where you can have very custom paths that the media can flow. It needs to be low latency. You need to be smart at every level, and it's not the same. And these things are kind of merging, where people who are on there's things like Clubhouse, and there's things like I was gonna say Twitter Spaces, but now it's X. Is that even a thing? I don't know. But people know about Twitter Spaces. There was HQ Trivia.
Right.
All these kind of things where there was a need for it to be telephony, like strictly, like it needs to be like a real-time conversation. But then at the same time, it needs to be also visible to many, many different people. So like these worlds are kind of merging, and it requires the servers to be smarter, right? And it requires the servers to receive these RTP packets and then get them to the right place. And kind of as these things are merging, there's need for the servers to be smarter. There's need to kind of push the more of the media logic, the more of the routing of the media logic that understands that this is WebRTC, this is RTP, this is a peer connection, to all the servers that are around the world. That used to be done. right?
Mhm.
They used to be just like dumb byte servers that serve bytes out. But that doesn't work anymore, because you wanna know what the content is. You wanna understand, all these different things. One of the things that we do at Cloudflare that's kind of cool, I think, to work, to have this, is that we have 285 plus whatever places where these data centers are, and then they have from a few to hundreds or thousands of machines in a location, and all these machines around the world run the same software. And when you want to deploy software, they literally all run the same software, they're all identical. And it's useful kind of to develop something, and then when you're making a DNS server or whatever, and have it go at scale. But at the same time, we can do the same thing with WebRTC, where we can have these media servers and deploy it everywhere. So that's kind of what we did, where all the Cloudflare machines everywhere, it's not like one or two places, talk WebRTC. Or for other things, we also talk RTMP, or we also talk kind of SIT, and you can do pull and push with these kind of protocols and play with them. And our kind of Cloudflare Calls product, how it works is you make a peer connection to one of them, and then you do go through the motions of doing it's not the word. The word's not negotiation. You go through the motions of making a peer connection,
Right.
and then you're homed at a server, but then somebody else you're talking to can be homed in another server that's closer to them, and then Cloudflare kind of takes care of all the communication in between. And the kind of the protocol that we care about ends at the first hop, right? It doesn't go to a centralized server and where communication is done. Whatever protocol you were talking over, it could be WebRTC, it could be whatever. It could be HLS, it could be RTMP. Obviously, not all these things are interoperable because of codecs and stuff like that, but that protocol layer ends at the first hop, and kind of that's kind of what we do. That is unique.
So from so you mentioned in the calls that you and I, if we're on different continents, certainly we would be we're using the same IP address, we're using with Anycast routing, but we may be connected to different data centers, and Cloudflare essentially is obfuscating that from us, for us as participants in the call, and or for the developers building that application.
Yeah.
They're not worried about dealing with that. That's all done behind the scenes, the routing between those different data centers. So
yeah, one example I give is when you have an SFU, right? Say you put the SFU into US East 1, right? So it's in Ashburn, Virginia. And no, it's not Ashburn, whatever, wherever it is. And you have a call between someone from San Francisco, someone from New Zealand, and someone from France, right? With these people, when they're on the same call, what's going to happen is the latency of the New Zealand person, say, okay, and then add the fourth person, Australia, for the example. The latency between the Australian and the New Zealand person will be limited by how fast those packets can travel with the speed of light all the way to US East 1 and then back. And it's not going to be a fun conversation for them, even though they might be used to kind of, if they were doing peer-to-peer, they might be used to kind of way lower latency between themselves. Because the SFU is in one single location, everybody's going to have a bad time, because everybody has to travel all the way to US East 1 and then back. And with Cloudflare Calls, everyone connects to the closest Cloudflare location, and Cloudflare makes sure people communicate between each other. And in that case, it always talks to the closest place. So if the New Zealand person is talking to the Australian person, they're probably, very close, so they're going to have a very good interaction, versus the bottleneck of speed of light will be introduced when they want to talk to someone in, say, France, right? Because Cloudflare needs to send those packets from the Cloudflare location from, Auckland or whatever to Paris. And then they, that communication needs to be established so that it's low latency. And what's cool, compared to peer-to-peer, where you don't have any control where the packets are flowing, because we end the protocol layer, on the first hop, we actually have visibility into what's happening, right? And, Cloudflare has all these cool technologies that I don't work on, so I don't know exactly how they work on underneath. That gives you this like magic, where sometimes we introduce another hop there, but overall the latency gets lower because of some congestion around the internet that that Cloudflare has visibility into, and every Cloudflare location pings each other all the time so that what the latency is, and the right path is taken. And there's all kinds of magic that you can do because you don't trust the public internet. And instead you use like, I don't know, Cloudflare backbone or whatever it needs to flow. The data needs to flow. So there's kind of cool things you can do compared to using like a SFU where you just put in to a data center. It's kind of like a distributed SFU or a serverless SFU or a switchboard kind of thing.
Right. Without having to be an expert in network engineering to make it happen. So
or having to run your whatever Dockers and have things talk to each other, and actually like network engineering is very hard, and there's a ton of people at Cloudflare that do this that I respect a lot, because I don't know as much as that they do, and it's actually very cool. When you look at the internet from layer 1, layer 2, kind of OSI level, lower parts of OSI level, because I usually live on like OSI layer 8, the customer portion, and going down is very cool.
Yeah, absolutely. All right, let's take a quick ad break here. And while we do that, we'll be back in just a moment with more questions for Renan. And so this is a great time, if you're watching us live, to enter a question on whatever platform you're watching, and we'll be sure to ask it after the ad break.
Building custom WebRTC video applications is hard, but your go-live doesn't have to be stressful.
We thought we were ready to launch our video application, but we discovered it's a lot harder than we thought. Live video applications are not like building other web or mobile apps. Our team worked hard out there today, but we just didn't have all the right pieces. I'll tell you what we should have done. We should have brought in the live video experts from WebRTC.Ventures.
If you're building a live video application, then trust the experts at WebRTC.Ventures to help you design, build, test, deploy, and manage your custom-built application, or integrate live video into your existing application. Contact us today at WebRTC.Ventures.
All right, we're back on WebRTC Live with Renan Dincer, Engineering Manager at Cloudflare. Renan, I want to hear a little more from you about some of the more interesting challenges that you all have run into in deploying Anycast routing. And in particular, one thing we talked a little bit off air was how you handled load balancing on edge networks. So maybe talk a little bit with us about that.
Okay, so let me see if there's a slide on this. There should be a slide on this. Okay, great. So these are the protocols we do. And when when you're talking HLS, when you're talking RTMP, when you're talking, Dash, you talk over TCP. And with TCP, it's easy to, when you're starting sending, packets, it's over connection, and it's kind of a reliable connection, and you have that little, path. And when you do kind of Anycast to a Cloudflare data center and then like to a server in between, it can remain somewhat consistent, because we have layer 4 load balancers that can specifically look at the IP port coming in, the for tuple coming in and say, okay, the destination should be this, and you can have some sort of a consistent flow of media, right? Obviously, it's not permanent. Your Wi-Fi can go down, or something on the internet can change, or the machine you're home that might fail on the Cloudflare side for some reason. But those are rare events. But most of the time, it's consistent. We do SRT, which is a protocol over UDP, but the signaling is in band. So it's still you can depend on the for tuple, the IP address port of the destination to make sure it goes to the same machine. WebRTC doesn't work that way, right? WebRTC is a collection of protocols. They all can speak. There's like IC, there's the DTLS stuff, there's the SRTP stuff, and all this stuff happens on different ports, and they go to different places, and they do they serve different purposes. And what it assumes, that this whole thing assumes kind of unicast routing, where you always assumes that the state of the negotiation, state of the peer connection, all the state lives in memory, and if you're sending something to a specific place, it's always going, the data and the state of the DTLS or ICE is going to be fixed. But that's not the case, right? At Cloudflare, very, very, very likely ICE will go somewhere else, and the detailed stuff will go somewhere else, and then the SITP stuff, ongoing, it'll go to another place. It'll be fixed because IP port is fixed, but it might go to a different place. So there's a bunch of like creative things you can do to solve that situation, which we're doing. For example, we store the ICE state in kind of a in a durable object, which is kind of a Cloudflare product that we also sell, which is a way to store data that is also a edge compute primitive that is single threaded, and kind of because it's single threaded, wherever the packets or the signals come from, they come in order, and you kind of have some sort of consistency in handling data. So we manage kind of the state of ICE from there. With DTLS, we do a bunch of magic with kind of deriving certificates kind of on the fly, using kind of a predictable way of generating certificates, so that it's not generated and saved, but if for some reason packets end somewhere unexpected, we can generate it, and we can like recover from that situation. That's also very useful. For example, if the server you're on fails and then packets start flowing somewhere else, we can be like, oh, okay, what was the state? Like, let's recover. And this can happen fast enough so that people probably won't notice. The RTP media flow, kind of the most important part of it, also can go land somewhere else. And this gets even more complicated because as you're trying to do ICE, you're probably doing like IPv4 and IPv6 at the same time, and these are going to land at different places, and something needs to detect and figure out, okay, especially if you're doing aggressive nomination at the when you're doing nowadays, you just don't know where things are going to go. So we do a lot of magic, kind of trying to figure out the state of the world, without having to distribute the state to all the many machines that we have, because that would be very expensive. That would be very kind of slow in some cases. And synchronizing like all the machines to have the same state is very hard. So we try to store the state in a single location and then add logic in a way that is not disruptive, so that if the state is missing, it can be updated. So kind of this state management situation with WebRTC, I think it's one of the worst parts of, obviously there's a lot of history here and people have opinions. But it's very difficult to manage all these things if you just don't know where the packets are going to end up. And kind of, you also need to manage states, because if you're, if you want to have a service that can update itself, and you want to change code, right? You don't want to disrupt whatever's going underneath. So you need to kind of save the state and then resume from the new process using the same state as the packets are flowing in. There's a bunch of problems to handle, which is, the difficult part. So that, we can pretend like all of Cloudflare is one computer.
Right. So we have a question from a viewer. Bilal asks, based on your experience, how would you compare the quality of a video call using a WebRTC peer-to-peer architecture versus an Anycast architecture? Is there a substantial difference in quality?
Depends on their ISP, right? If you are in a one-to-one conversation, right, in theory, this shouldn't matter. But if you have another person in the conversation, the amount of data that you need to transfer from your computer increases exponentially, right? So yes, exponentially, where if there's 5 people in the conversation, you're sending your media to 4 different people, and you're different people's different internet speeds are different. But where I'm from, I get gigabit down and very terrible amount up, and because I'm connected over cable, so that kind of eats into the whole quality story, right? WebRTC is great because it adjusts the quality depending on internet connection, but if the internet connection goes bad, you don't. Versus if you're using some sort of a delegate, right, between you that receives all the media you send and then handles the distribution on the server side, where you're going to have very good internet connection because it's a server, you're going to have very, very good quality. So another thing is that ISPs usually optimize the way they do internet paths so that it has good connection to big service providers, like Google, like Facebook, like Cloudflare, right? And we can take advantage of that good path, whatever that is. So kind of depends on their ISP, but the answer is kind of yes. You can have good quality, especially if there's many people, because you're using taking advantage of the whole like SFU situation.
Yeah, so it varies a lot with the use case, right?
Yeah.
And you mentioned something like the HQ trivia game, for example, right? In a case like that, you care most about latency, right?
Yeah.
Because the timing of people answering questions is incredibly important to the game, right? So you care more about latency than quality there. So I guess would you say in general that Anycast is more about improving latency or quality, or just like a guaranteed connectivity, or again, depends?
All of the above, kind of. But the Anycast is useful just because of definition. It's going to go to the closest place, right? And if all the places are on the same software, it's going to be I've seen a WebRTC connection that if you open WebRTC Chrome internals, Chrome WebRTC internals page, you see I saw 2 milliseconds of round trip time from my friend's home internet connection, which is like crazy. But
Right.
they live close to a Cloudflare location, and like it's great, and their ISP is great, and it just looks good. I get 10 milliseconds, but these numbers are just so low compared to if you want to send a packet round trip time, you're going to get like 200, whatever, like if you're sending packets to Europe. So kind of latency is greatly improved, and because of that, a lot of other things are also improved, including quality, just because of the fact that there's less chance of packet loss at that layer where between where WebRTC handles the congestion control, right? Because you have just wide open to the closest place lanes. Obviously, whatever happens over the public internet, Cloudflare probably can do a good job because we monitor these things, and you leave less to the black box of WebRTC and whatever client device you're using, and you have more control.
Yeah. Now, from the developer's perspective, who's building their WebRTC application, obviously you're obfuscating a lot of that, the network engineering challenges and topology challenges for them. Is there anything different in how they build the application to take advantage of this? Anything different in terms of how they might manage state in the application or rooms or something like that?
Yeah. So in Cloudflare Calls, we chose not to do any SDK kind of thing. And so if you're doing a regular peer connection, what you do is you make a peer connection with Cloudflare, and then you add tracks onto it. And when you add tracks onto it as part of the kind of signaling, we give you an ID, which you can go back and pull from a different peer connection of your choosing, right? So there's no, we don't present any kind of native concept around the room or any kind of thing like that. You have peer connection, you have tracks on the peer connection, go do whatever you want. And this could mean that you can build a broadcasting application where just one person pushes something and everybody else pulls, which is fine, totally valid, it works. And it can work to, I don't know, whatever, like hundreds of thousands of people. The other portion is you can have like a room concept, which you manage. You can have a server, whatever language, whatever platform you run it in, and you manage the room and you decide who pulls what, right? And similarly, you decide how to manage the limited connection speed of your browser, right? You might be pulling, you probably can't pull 1,000 different tracks at the same time, right? You're going to run out of, connection, and you have to manage, okay, like what's the subset, what's the priority, like you manage all these different things. And this is kind of useful because it's a very nice boundary that is very well defined by the WebRTC spec. So, you don't have to wrestle with an SDK and like how it manages the concept of rooms and how does it scale. You don't have to worry about these things. Kind of the only limitation we have is that you can add 50 tracks per second to a particular peer connection, which is again like way more than you would do on a particular client, because are you really going to pull 50 more than 50 people at second to your client? No, you're not going to do that. And kind of that's kind of the only limitation. And the other limitation is what is your what can your client do, right? And that's kind of how the arrangement we decide works, because there's a lot of use cases where one of the examples that I give very often, and around the second time hearing this, is this yoga case where if you have a yoga class, you want using Zoom or whatever, it doesn't really make sense because the room doesn't make sense. You want the yoga teacher to be able to see all the students, but the students don't need to see the other students, right? Or maybe like there's a exemplary student or a coach or whatever like that's in the class where you see them as well, but you don't want to see everybody else. And there's this all these unique cases that don't really map to the Zoom. And you see this during the pandemic, everyone tried to do like a Zoom version of their thing, and it kind of sucked. And it was kind of weird, why do you really you want the teacher to see you, but you don't want other people to see? And how do you do that in Zoom? You can't, and then there's this concept of breakout rooms, which is great, but then it's kind of confusing. And then kind of all these kind of concepts, I think it's really limited by your imagination.
Yeah.
And different people have different use cases. And kind of, I think we're as humanity, we're learning how to map these things to like digital life, right?
Yeah.
And you need a lot of like flexibility, a lot of room to do that. And we thought, okay, like rooms are kind of weird situation that we shouldn't really think about. And people are very good with I don't know, like standing up a Rails server or whatever, and like or JavaScript framework of today,
Right.
to manage these things that need to be managed in to synchronize all these different clients, because people do that all the time. People know how to use WebSockets, and people know how to. You don't even have to use WebSockets. You can use like polling or whatever you want to do. And we take care of the kind of like the important part, which is the low latency network, whatever, the part that is kind of confusing. And some of the signaling, and then you decide what resolution video you're going to send, and you have access to all the WebRTC internals like sets. You can decide these things if you want to really tune it very hard, or you worry about the codec compatibility. When you make SDKs, oftentimes people overlook these kinds of like codec issues between clients, and like and
Right.
different people have different requirements. If you're making an app for people with lower power devices, versus if you're making an app where you absolutely know everyone is like on the fanciest new device, it's kind of your client base, them, and you can make decisions in a good way.
Yeah, absolutely. I really like the yoga example that you give, because it helps to highlight how, if you and these are important things for businesses to consider as they're considering building a custom video application. That's what we do at WebRTC Ventures. And if someone's only experience is kind of a very prescriptive type of solution, like using Zoom, and they're like, oh, but I want Zoom for this, then they're very constrained by the way that tool operates, and thinking only about a full group conversation versus a breakout room type of thing, right? But the yoga room example, a lot of ed tech examples are not, shouldn't be constrained by that mentality. And so having your, choosing a platform to build your application on top of that allows you more flexibility, like you described, to just add and remove tracks as you please, allows for lots of different ways that you could implement that yoga class scenario, right? I could volunteer to put myself up on the stage, perhaps, or I could be selected by the moderator, or, the top person on the leaderboard gets put up on stage, right? There's all sorts of things that we I don't know whether that's a reward or a punishment necessarily, but right. But there's lots of different ways you could think about that having that flexibility in the implementation and the API that you're using is really important. So we're nearing the end of our time here. If there are any final questions, it's a great time to ask it. We do have one from Philippe I'd like to ask. So Philippe Sultan says, LinkedIn, thanks a lot for this excellent presentation. I'd like to know more about which server IP addresses are managed with Anycast. Do Cloudflare calls work similarly to the now discontinued Subspace service that is enforce RTC peer connections to use ICE candidates generated from turn servers announced via Anycast, or maybe this is managed completely different? Thanks for your question, Philippe.
If you leave, there's many parts of the question, so I would love if you leave the thing on the screen for a second. Okay, so I'll go in order, I guess. There's only one server IP address, well, v6 and v4, right? That we manage. So there's nothing like crazy about this. The service has an IP address that we advertise every single place, and that's kind of how we manage the service. Because of this, we actually don't need a turn server. So we're very, very different than Subspace, because we don't use turn servers. You can just connect to, Cloudflare, and Cloudflare will talk the service you want to talk. And I don't know much about, Subspace. I haven't used them. My understanding is that, they were a turn service kind of that would use Anycast, and Pirate Turn is a a blind proxy, kind of like a VPN, right? And actually, if we were to use Turn with Cloudflare calls, it might even introduce a little bit more latency depending on kind of where the turn service is, because you're jumping from one place to the other instead of just talking natively to us. So what we do is we give you kind of one IP address to do, your negotiation with, and in the ICE candidates, you go get that, and then you talk to that in your, you do signaling with us over HTTP. And there's literally 5 API calls in, Cloudflare calls. When you do, you want to create a peer connection, want to add a track, want to remove a track, want to get the list of, get the description of what's in the peer connection. And the other one is to stop the peer connection entirely. And that's it, right? You just add remove tracks. So, it's not like, you don't see any of the kind of remote IP situation here. You just talk to us, and then you send us the tracks, and we natively know, and you can see like, these are tracks you're pushing, and this is the media ID. So it's a little different, I think, than Subspace, and there's not many IPs to manage.
Excellent. That sounds like a good thing for sure. And the less, it's certainly one of the most common things that when people are just working with WebRTC for the first time in general, is the complexity of dealing with a turn server, or they don't realize they need a turn server if they've just gone from a demo of a peer-to-peer application on a controlled network type of thing, and then they deploy it in the real world and see problems with turn. Or not having a turn service. So the more that people can get away from that, certainly that is easier.
Like turn servers, right? Turn servers are useful, right? Like turn servers are useful if you have very specific issues. Like if you're doing peer-to-peer connection and the other side is like behind the NAT, you have the issue. But we have a public IP address, right? Like we don't have to worry about being behind the NAT. It's also useful if you have kind of weird corporate, firewalls that block stuff.
Right.
But like, yes, that's a valid thing. You can have weird corporate firewalls, but it's been a very long time. I feel that I've seen a situation like that where it required every single person to get a turn server deployed, right? Maybe you need a turn server because you're the problem child. Again, like I think maybe problem child is the wrong word, especially to use with like a corporate audience. But,
right.
Like there's solutions to that problem that is like very specific solution that needs to be introduced when there's a specific problem. Using turn everywhere most of the time is not a great idea in my opinion. It's kind of similar to people when people talk about, look, just use a VPN, right? It's more privacy. Sometimes that's the case, sometimes that's not the case, but that's kind of something that needs to be talked in the beyond marketing, I think.
Yeah, absolutely. All right, well, Renan, sadly, we're at the end of our time here, but I really enjoyed the conversation with you, and thanks to all of you who watched today and for your questions. Any closing thoughts or anywhere you want to direct users to learn more, Renan?
Yes. Well, it's great, talking to you as well. Cloudflare Stream, Cloudflare Calls are the two products that we use kind of WebRTC for. And they have kind of websites / blog posts that you can learn more about. Cloudflare Calls is in closed beta, but because of how closed betas work, we can just add you and then you can try, and hope to get it out of closed beta soon.
All right, excellent. Well, thanks again for joining us today. I really enjoyed speaking with you, Renan.
Yeah, me too.
As always, this video will be available on the WebRTC Ventures YouTube channel, as well as on our blog at WebRTC.ventures. And speaking of places, great conversations, I'd love to have a great conversation with you. There's a number of events coming up where we can speak together in person, perhaps. I'll be at the Voice and AI Summit in Washington, D.C. In the beginning of September. So let me know if you'll be attending. I'll be happy to meet up there in person. In October, I'll be at the TAD Summit in Paris and moderating a panel on AI and communications applications. And then at the end of November, I'll also be attending the AWS reInvent conference in Las Vegas. So if you'll be at any of those and want to meet up in person, just email team@webrtc.ventures to contact us and set up a time. Our next episode of WebRTC Live will be Wednesday, September 20th at 12:30 p.m. Eastern US. Our guest will be Daniel Phillips, lead UI designer here at WebRTC Ventures. He's going to talk with us about some must-have design elements for successful video applications. To find out more about our upcoming episodes, follow us on social media at WebRTC Ventures. Subscribe to us on Twitch, LinkedIn, YouTube. And don't forget to join our email list at WebRTC.ventures. Thanks, everyone, for joining us today. Let's make it live.
Thanks for joining us for WebRTC Live. Visit our website at WebRTC.ventures to learn more about our custom design and development services and to learn more about upcoming episodes of WebRTC Live.